All right, so today this is Henning and I are going to be talking about focusing on the long term, being good for users and for business. And this has worked for many people, not just the three of us who are the authors. All right, so what do we really mean by this? So as Ronnie mentioned in his keynote yesterday, internet companies are starting to run online experiments to test out their ideas because they have no idea if they're actually good or bad. Now, typically, these online experiments are run in the short term, so days or weeks, to actually make a decision. Now, at Google, it's the same thing. We run most of our experiments for days or for weeks, but what we've also found is that sometimes those short-term results don't necessarily predict what happens in the long term. After you've launched your change, it's out there for months, and users really adapt to the change. So given that we actually want to run a business that optimizes for the long term, the question is, how do we construct an OEC, an overall evaluation criteria, that can predict that long-term impact, but using metrics that we can measure in the short term? So to do this, we do three things. The first is an experimental design that actually can cleanly measure the long-term impact. From there, we build a model to be able to predict that long-term impact given the short term. And then the third is to actually construct the OEC. Now, while the methods we present are generally applicable, the specific areas that we focus on is going to be on ads blindness and ads sightedness. Now, what is that? Ads blindness is generally the idea that if you show users crappy ads, they stop. They basically ignore the ads. This is a learned visual inattention, and ads sightedness is the corollary. If you show users good ads, they start paying attention to ads more. Now, given that so much of today's internet economy is actually still driven by advertising, really being able to quantify and understand these effects is going to be increasingly important if we want to have a sustainable economy. So let's make sure that we're all on the same page. What I have here are screenshots from 4 different search engines, Google, Bing, Yahoo, and DuckDuckGo. And it's all for the same query, Sydney, Australia. Now, all 4 of these search engines show a different number of ads, even different advertisers. They have different UIs. And so what's happening is that all of these companies are basically testing out changes to try and optimize their ad system, both for users and for the long-term business. But you want to innovate quickly. You basically want to be making decisions quickly, but you want to make sure you're actually doing it for the long term. How do you make these decisions? Now, why do I keep saying that this is a long-term phenomenon? Well, let's take a step back. Why would a user actually interact or click on an ad in the first place? Well, if we look at click-through rate, so defining click-through rate as being clicks divided by ads, and it's worth noting, given how many questions that I've gotten on this, that we focus on click-through rate because we have not seen a change in usage. If you actually seen a change in usage, you can't focus on click-through rate alone. But given that we haven't seen that change, we focus on click-through rate as the primary measurement of a user interacting with an ad. What we posit is that click-through rate is dependent on 2 factors. The first factor is going to be mu, which is going to be the ad itself. How relevant is the ad? Is it visually appealing? Does it have useful information? But there's another factor, and that's going to be lambda, and that's the user attitude towards ads. How willing is the user going to be to actually consider the ad in the first place? Now, the key thing to note is that click-through rate, mu, and lambda can all change over time. Right? So mu changes over the short term as you run experiments and you launch changes to your actual system, whereas the lambda, the user attitude, changes over the long term. Because what happens is that as users have experiences with ads, then they're going to change how willing they are to actually try future ads, right? So as they have good experiences, they're more likely. As they have bad experiences, they're less likely to try the ads. All right, and so our goal is to be able to measure and predict this change in the user attitude. This is ads blindness and ads sightedness. So how do we do this? Well, we basically start with all the randomized experiments, right? We basically want to measure this change in attitude given proposed change to the system. And this is basically done via these randomized online experiments where we basically create an experiment cohort by having a randomized set of users in E, and then we create another randomized cohort, which is going to be C, and to one we serve the experimental treatment, and the other one we serve the controlled treatment. Typically, these experiments are run in the short term, so days or weeks. If you want to measure a long-term impact, the first thing you have to do is actually run it for the long term. There's really no way around this. All right, and so what we can say is that in the short term, right, there's really no change in the user attitude between the experiment cohort and the control cohort due to randomization. All right, so what we want to do is we actually want to measure this change in the user attitude in the long term. Unfortunately, we can't measure the user attitude directly. What we can measure is going to be click-through rate. So at the beginning, in the short term, if there's no change in the user attitude in the short term, then any change in click-through rate is going to be dependent solely on the actual serving changes that you've made. Can we use that in order to actually measure a change in the long term? Basically, can we actually derive the change in the user attitude from the change in click-through rate? So unfortunately, no, because the change in serving isn't necessarily going to be constant over time. If you're basically running a typical website, you're making changes all the freaking time, and so it's not actually going to be constant. Plus, you have query mix changes, seasonality, all of those things, right? And so one of our key observations is that you can only derive the change in the user attitude from the change in click-through rate if serving is the same. All right, so how do we do this? Well, the first thing that we do is we do a post-period measurement. So the idea is that you still run your long-term experiment, but at the end, instead of actually taking the measurement when the serving streams are actually different, you actually take a post-period measurement where you basically take your experimental cohort and you bring it back to the control serving. So now serving is the same, and that means that any change in click-through rate, assuming usage is constant, that can basically be attributed solely to the change in the user attitude. Basically, it's due to their exposure to the experimental treatment over time. Now, what we're really doing here is we're leveraging the carryover effect that Kohavi observed and that we've also observed independently to really measure user learning. Now, there are several challenges here. There's a whole bunch of challenges with regards to statistical power. I encourage you to read the paper to get more details there. There's simply not time here. But the other issue is that this takes a long time. And moreover, you don't get any intermediate measurements until you actually take your post-period measurement. And so if your user, so do you know, does your user learning take 1 month, 2 months, 3 months? How do you know? Right? So ideally, you come up with some continuous measurement methodology so you can take intermediate measurements. So what we came up with is something called Cookie Day. And the idea is that you still have your experimental cohort E and your control cohort C, but now what you do is you also have what we call E prime. All right? And the idea is that you have, beyond your E and your C cohorts, you have all of these other users that are neither in your experimental or your experiment or your control that normally get the control treatment. And what you do is you pull a small subset of those users daily, so it's basically re-randomized daily, and now you can take a daily measurement. Right? This basically hits all of our major issues, right? So on the one is that the serving is the same, right? So they both have the experimental treatment. The key thing to sort of note is that now the experimental cohort E is the one that's basically accumulating learning, while the daily randomized ones basically have no accumulated learning, and so therefore any change in click-through is again the accumulated user learning effect. Now, does this work? Absolutely. So what we have here is a grid of 10 experiments where we're basically changing a bunch of serving parameters. We can show more ads, fewer ads, we change how we choose the ads, a bunch of different things, right? And so on the x-axis, we have time in weeks, and on the y-axis is this change in the user propensity to click. All right, now the first thing you'll say is, well, your first point's not 0. You said it's going to be 0 because of randomization. And what I say back to you is, yes, it's a 7-day average. If you take it at 0, it really is 0. So that's one point. The second thing is that you see both blindness and sightedness. It's not just one or the other, right? You can see the effects in both directions, and you can see different magnitudes with different treatments, right? And the final point that I'll make is that the effect plateaus over time, although it's only after months of treatment. So now I'm going to turn it over to Henning.
Okay, so Diane told you how we go about measuring these learning effects, right? So we run these long studies. They take several months, usually 3 months or more. And that's, of course, very cumbersome, right? And I'm going to tell you about how we model these user attitude changes towards ads. And so why would we do that? Well, first of all, I already said it, you want to predict this, right? You don't want to run long-term studies for every serving change or every idea that you have, right? It's just very cumbersome. It takes a long time. It's also very expensive, in fact. But maybe more importantly, if you're able to understand the characteristics that are predictive of these user attitude changes, you actually understand what drives ads blindness and ad sightedness, right? And that understanding will probably change your decision making in a way that goes beyond like a prediction from a model. And as an application of these models, I'll tell you how we define an overall evaluation criterion to evaluate online experiments. And that's very much in the direction of what Ronnie Kohavi said yesterday. You have to have the right objective to optimize for. And we're taking a long-term objective, and I'll tell you how we construct that objective function. So what kind of models am I talking about here? They're actually quite simple models. What are the inputs and the outputs? So if you run an online experiment, you can measure a host of different metric changes, right? I've seen several slides here from LinkedIn, from Microsoft, that they measure thousands of metrics. That's right. That's what we do as well at Google. You might measure changes in the click-through rate, in how many ads you show per query. Maybe you have a metric that's some sort of relevance score that tells you the correlation between the query text and the ad, or the query text and the landing page content, right? And so measure all these things, and from that we want to predict how user attitudes towards ads, the inherent propensity to interact with your ads, changes. And to be precise here, on the left-hand side, the inputs will also be relative changes in these metrics. That's why I added the delta in this thing. And the subscript 0 here is supposed to indicate that these are really things you can measure in the short term, basically at time t equals 0. And from that, we want to derive how user attitude changes after a long period of time when they're exposed to this treatment. Okay, and what we found at Google generally is that models whose covariate are ads quality metrics are highly predictive of how users' attitude towards ads will develop. And more concretely, the simple model that you see here is really just a 2-variable linear model. One covariate captures the change in ad's relevance, something like CTR. In practice, we use something slightly more complicated. And the second term is the change in the landing page quality. That means the quality of the landing pages that a user gets to after they click on an ad. And you can see in the plot that where on the y-axis you find the actual learning measurements that we've taken from our long-term studies. So this is about 100 and something points. This is our training data, so it's, each dot is a long-term study. And on the x-axis, you see the corresponding predictions from the model. And you can actually, it's pretty clear that a large part of the variability in the measurements is in fact explained by the model. And that works for a fairly wide variety of system changes, like system parameter changes, algorithm prediction changes, right? Prediction algorithm changes, or changes in targeting of the ads. And one class that's not mentioned here are UI treatments. And in fact, these UI treatments are sort of a different animal, and they're not covered here. And we've done separate studies for those. And generally, we find that the effects, the learning effects, they're actually quite weaker. So the major drivers are the quality of the ads that you show. And so how do we choose and evaluate these models? Well, first of all, some cross-validation stuff, right? But if you see I have 150 points here, even if you do cross-validation, you're likely to end up overfitting. And so what we really care about is the prediction accuracy on new long-term studies, on new test data that we get from new experiments or launch holdbacks or something like that. And finally, you might say, this is a very simple model. Couldn't you do better? And the answer is, in terms of prediction accuracy, the improvements from doing fancy things were small, and we like it interpretable, so we stuck to these simple models. Okay, let me tell you how we use this to define an OAC for online experiments. So if you're an ads person, maybe your objective is revenue. If you're an ads person that wants to still be in the business 2 years from now, your objective might be long-term revenue. And so that's what we pick as our OAC. And let's see how this comes about. So how does Google generate revenue? Well, users come to Google, they do queries. On some of these queries, we'll show an ad. Sometimes they click on the ads, and then we get paid, right? And if you look at this chain, you see that user behavior changes affect several factors here, right? Users might or might not come to Google for their tasks if they have a bad experience. And they might or might not interact with our ads, right? That's the second term. And so on Google.com, we actually only see changes in that latter term. In that second term, we don't see changes in usage. But we've done experiments with partners, sites that have a much higher ad load, and there we could actually see that the usage, how often users come to the site, changes based on the ad load. But on Google, okay, we can focus on the click-through rate. That's exactly what Diane explained to you, how we measure it. And so now we can write down an estimate for the long-term revenue impact, okay? So we take long-term revenue as our OAC, and I claim we can write a change in long-term revenue as the change in revenue that you measure right away when you start your experiment. So that's simple. Plus a delta lambda infinity, this is the change in users' attitude towards ads. And why can I just add this? It seems like I'm adding money and attitude or something, but these are all relative changes, so it's a dimensionless equation. And in fact, it turns out that if users are 1% more likely to engage with your ads, revenue goes up by 1%, at least for Google, that's the case. And so I can just add these, okay? And so I end up with an OAC that says, okay, the long-term revenue impact of your launch is the short-term revenue impact, plus this term that measures, in some sense, the quality with which users perceive your ad, okay? And so if you care about revenue, and if you care about revenue even 2 years from now, you better care both about revenue and quality. And that's an OSC we use widely at Google to make decisions whether to launch something or not, because it's very easy to increase revenue at the expense of quality and vice versa. Okay, let me give you some applications. One thing we did, well, we changed the ranking functions based on this research. So the model that I showed you earlier says pretty clearly you need to pay attention to both ads relevance and landing page quality. That means the user experience after a user clicked on the ad. And so we had a eCPM auction, like many places have, right? It's basically optimizing for short-term revenue. And we wanted to change that ranking function to include these long-term effects. And we did that in October of 2011, and now we have a ranking function that we call the long-term value auction that explicitly features long-term quality measures, basically. The second application is to ad load. I think that's a problem that every website, every publisher grapples with, how many ads to show, right? And from a short-term perspective, the solution is easy. More ads, I'll get more money. But in the long term, that might not be true, and that's what we've seen at Google. So the data that you see here is from an experiment that we ran about 2 years ago, where we showed that the treatment shows more ads on smartphones, more search ads. And you see in the pink line that there is an increase in RPM, in revenue, goes up. And it stays up because this is measured with new users every day. Okay, so the short-term effect is positive. Great, let's show more ads. But when we did the long-term study, and this is what you see in the blue lines here, and this study is very long, right? It's 200 days on the x-axis here. You see that the revenue gain actually disappears over time as ads blindness kicks in. So this decline in revenue is actually driven by users interacting with our ads less, because the quality went down because we showed more ads, and those additional ads were of lower quality than what we showed before. And in fact, our methodology is very likely to underestimate these learning effects. I can't go into this here. We'll say a bit more in the paper about this. So we believe that at that point in time, we were actually showing more ads than was revenue optimal for Google. Even if you don't want to do the right thing for the user, which we also want to do, and it's very important to us, but even if you only cared about revenue, you would have said we should really show less ads. And that's what we did. Over the course of 1.5 years, we scaled down the ad load on smartphones by about 50%. And these studies allowed us to do that and told us we did so without revenue loss. And in fact, we think we're better off than before, both for users and for us. Okay, in summary, short-term effects and long-term effects might not be the same in your experiments. So look out what you do. The first step towards this is look at quality metrics, look at user satisfaction metrics, and then you'll be able to more likely do the right thing, both for users and for your business. And the applications here were all given for ads blindness and ad sightedness, where we replace the auction with an auction that's more forward-looking, more quality-oriented, and we reduce the ad load on Google.com. And in the future...
So I think one of the big questions is, does this actually generalize beyond either ads or beyond Google, right? And so as Henning mentioned, we actually have run experiments on other sites besides Google, and what we've seen are actually even stronger results, right? Specifically, usage actually increases as they reduce their ad load, right? And so that's been an interesting validation of the methodology, and also showing how we can basically look at things beyond click-through rate. I think the other question has been, does this actually work for non-ads? And again, we've actually applied this methodology, for example, to other features on the search page to understand user learning effects. Now, in terms of future work, I think one of the interesting questions is, with regards to ads blindness, what's the cross-system impact? Does the user attitude on one site actually impact how they view the ads on another site? Especially given today's internet economy, I think that's going to be a very important question. I think, we've mentioned numerous issues with regards to estimation and prediction, and we always want to continue improving those. And then the final point that I'll make is that the OEC that we have really focuses on the Google business and on users, but not on advertisers. And so figuring out how to actually include the advertiser response in an OEC is an ongoing area of work.
Thank you, guys.
Hey, Maria.
Hi. Have you experimented with explicit user feedback in addition to the implicit measures that you're collecting as a potential predictor of this long term?
We certainly run experiments in the past with regards to trying to gather explicit user feedback, like on the search page and things along those lines. Getting explicit user feedback is actually very damaging to the user experience. Like,
Sometimes.
Yeah,
Depends
what
on
we
how
found
you-
generally is that people like stop interrupting me and trying to do something else. But we have actually gathered that. What we have seen, basically, a lot of the measures that we sort of use are basically validated by the external user feedback as well. For
Okay.
the subset of users that actually give us the user feedback, which then has its own bias issues, and you kind of
Sure,
go
sure.
from
But
there.
I was just wondering if that explicit user feedback could predict your lambda a lot sooner than.
Actually, that explicit user feedback is usually more noisy. It's actually harder to get good data that way than it is to get this way. This is hard enough, but getting direct user feedback has been very difficult as
Okay.
well.
Hi, I was wondering when you make the model of the evaluation criteria, so you had this A times something, B times something, do you somehow get error bars on that? So can you estimate how good is your prediction of the long-term evaluation criteria?
Why does it not come back? I don't know. So I guess I'll give the answer without the formula. So the prediction from the model actually is not usually very noisy. The revenue metric, the short-term revenue metric, is usually the much noisier part there. And for the quality part, it's more like a bias issue than a variance issue. So when we plug it in, basically it's not very noisy at all, and the majority of the noise comes from revenue noise.
The question is a bit more whether, I can imagine your model is not predicting all the time perfectly what doing your long terms, whether you could somehow get a confidence interval of how good is your prediction of the end result.
Yes, so we do that, but as I said, the part of the noise that comes from the model is actually small compared to the revenue noise. So